So 4.7 is inverse trig functions. Recall from previous knowledge that for a function to have an inverse function, it must be 1-to-1. Or pass the horizontal line test. When looking at the graph of the sine function, you can see that it does not pass the horizontal line test. So remember, if you look at the sine function, it looks like this. So if we drew a horizontal line specifically right here, it doesn't matter where it's at, it'll cross through 2. However, when you restrict the domain, to the interval negative pi over 2 less than or equal to x less than or equal to pi over 2, the following properties hold. So on the closed interval of negative pi over 2 to pi over 2, the function y equals sine x is increasing. So I want to show you what this looks like. I know you guys are going to ask. All right, so here's a regular sine, not restricted, so it just keeps repeating itself. But if we change our window and restrict it from negative pi over 2 to pi over 2, and I'll even do it by pi over 4, so whatever. You can see that it'll pass that horizontal line test. That's basically what it's showing you. Okay, so we don't have anywhere in this domain, so this specific domain, where I couldn't put a horizontal line. Does everybody understand that? So we're going to domain restrict it so that it becomes 1-to-1. So on the interval, that same interval, closed interval, negative pi over 2 to pi over 2. Y equals sine x takes on its full range of values from -1 to 1. So -1 less than or equal to sine x less than or equal to 1. So I'm going to show you that too. And then you guys can see it a little bit better when I restrict this domain. I can't make it any darker. Yeah, that's as good as it's going to get. So you can see that it's fully increasing. There is no horizontal line that we have to worry about. And then I made it from -2 to 2, but -1 to 1 is its full range of values. On the same interval, negative pi over 2 to pi over 2. Y equals sine x is 1-to-1, and we just talked about that because it will pass the horizontal line test. So on the restricted domain, of negative pi over 2 less than or equal to x less than or equal to pi over 2. Y equals sine x had a unique inverse function called the inverse sine function. It is denoted by y equals arc sine x, or y equals sine to the negative 1x. That negative 1 always represents an inverse. The notation of sine to the negative 1x or the sine inverse x is consistent with the inverse notation. I told you you've already seen it when we did our inverses f to the negative 1 of x. The arc sine notation comes from the association of a central angle with its intercepted arc length on a unit circle. So arc sine x means that the angle or arc whose sine is x. Both of those notations, I'm going to rewrite them again. Arc sine x and sine inverse x are commonly used in mathematics. So remember that sine negative 1x denotes the inverse sine function rather than 1 over sine x. It's not the same. And then just like I showed you, the values of arc sine x lie on the interval from negative pi over 2 less than or equal to x less than or equal to pi over 2. So if we have our sine curve, it restricts it basically from your maximum to your minimum. All right, so that's just giving you background of what arc sine and the sine inverse are. That's it. Same thing. Arc sine and sine inverse are the same thing. The inverse sine function is defined by y equals arc sine x if and only if sine y equals x. All right, so I'm gonna show you this real quick. This is not important to know. I just want you to show you why it's the way that it is. If we have sine y over x and we're trying to solve for y, we're going to divide by sine. Our power of sine right now is like a positive 1. So it's not sine squared, not sine cubed, it's sine 1. And then to be able to put it on the top, we have to change the sign of the power to a negative. So that's why it's denoted the way that it is. X is between negative 1 and 1. And y is between negative pi over 2 and pi over 2. Why is this backwards? Because the other one said sine x was that way. What is this one? The inverse. Yeah, so the inverse is going to flip it around. That's all it is. So what was your domain is going to be your range, and what was your range is going to be your domain. Does everybody understand that? So that's why they flipped. All right. The domain of y equals arc sine x is negative to 1 to 1. That's what we just said. That was our range. Now it's going to be our domain. And our domain becomes our range, negative pi over 2 to pi over 2. Don't stress out too much because you do have a sine inverse on your calculator. Do you want to take the trash can? Okay. Okay, check on her, make sure she's okay. Like literally. Yeah. Don't get too close to her though. You don't need to throw up. All right. So evaluating the inverse sine function, if possible, find the exact value. We want this in terms of pi. So we want this in terms of pi. So I'm sorry, what? Yeah. So we have arc sine of negative 1/2. So this means we have sine inverse. And I'm going to write it as negative 0.5. Our formula a minute ago said this. Yeah, same thing. All the same thing. All right. So we're going to change it because I need to do it in terms of pi. Like I could put it in my calculator and get a decimal all day long. That is fine. Like don't stress out too much about whether you're going to use radians or like just decimals, but we're going to go ahead and I'm going to show you how to put it in terms of pi. Okay. So we're going to change this to say that sine y equals negative 1/2. Think about your unit circle. Think about your unit circle. If your coordinate is at 1/2, like your sine is 1/2, where are we at on the unit circle? What is sine? What? Say it again. Sine is your y coordinate. I'm gonna show you a unit circle so you don't stress out. Where is our y coordinate? 1/2. Okay, we're doing radians. Pi over 6 is where it's 1/2, right? So watch this. Negative pi over 6. That's it. So it's all based on that unit circle. Okay. The next one is sine inverse square root of 3 over 2. Go back. Sorry, y'all. There's a lot going on right here. Where's your square root of 3 over 2? Pi over 3, or if you did it 60 degrees, I'm going to show you both. Okay, so you guys try to give me the degrees a minute ago, right? So maybe you remember that it's 60 degrees, but you don't remember your pi. So we know it's pi over 3. We're done with that. We can do it by just the coordinate. Or is it 60 degrees? Let's remember how to do this. How can I change 60 degrees into radians? Do we need to call like the nurse or? Say it one more time. Okay, I'm gonna ask one more time. Ask her if she needs me to like call the nurse or anything like that. Like, okay, for real. Like this is not a joke. How do we change it from degrees to radians? We got to put the pi back on the top of 180. 60 divided by 180 is pi over 3. So I don't care which way you do it. You can do degrees, you can do radians. It doesn't matter. It's confused. And she says she's had an allergic reaction to something. She's been having, she's gonna grow up, she's breaking out. Yeah, right, so. No, she is in the bathroom, right, the 500 hot. Her face on it. No, it's not, it's not wet. Sorry, I don't want to play with that. All right, sine inverse of 2, what do I do? I can write it as sine y equals 2. What did we plug 2 in for? What was our x values? Where are our x values? Go back to that first sheet that we just did at the very bottom. Where could our x values go for the arc sine? That doesn't include 2. So this one is no solution. So be careful about that. Everything that we have has to go between 1 and -1. That's what you're doing. That, where is that coordinate? Yes.
I thought the -1 would change it, like.
You're good. All right, so then we're going to sketch, and I'm not going to do too much of this sketching. We just did a couple. Straight down the middle. Remember, if it's an inverse, it's flipping it. So our sine curve is going horizontal, arc sine will go vertical. Remember, we go from 1 to -1 on the x-axis now. And on the y-axis, I'm going to go ahead and go up to pi and -pi. But what do we go to make sure it's 1 to 1? What were the values that we had to make sure we restricted it to? Pi over 2 and -pi over 2, right? So we're going to kind of restrict it here. What that means is it's going to repeat outside. This is just a plain arc sine. Same thing as before. It's going to go through 0, 0. And then when sine is pi over 2, regular sine is pi over 2, our value is 1. So we rotate those coordinates. So you would have 1 and pi over 2. So if I plug in sine 1, I get pi over 2. Somebody in there with her? Thank you. All right. So if I plug in -1, what am I going to get? Negative pi over 2. So this is what it would look like if it were restricted. It goes back to 0 for your pi and -pi. So this would be your full wave before you started over again. So your full period. Does everybody understand that? But again, to be 1 to 1 and to work, we need it between the 2 yellow lines. What is 2x going to do? Stretch it, right? So here's what it does. You're going to draw your graph the same exact way. Don't do anything different. -1, -1, -pi over 2, pi over 2. This time I'm not even going to go any further than that. Instead of your x value being 1 with arc sine 2x, it's now going to be 1/2 pi over 2, 0, and negative 1/2 negative pi over 2. Like this. Okay, and you knew that it was going to stretch it. So instead of being a really fat graph, it's going to be a skinnier graph. Again, all those graphs you can put into your calculator, so don't stress about it. If it's on the test, it's not going to be a hand graph. It's going to be manipulate the calculator so you can pick out which one, just like we did on our quiz, which you did very well on. All right. Other inverse trig functions, the cosine. Is decreasing and 1 to 1 on the interval 0 less than x less than pi. So remember when we were doing that bx minus c equals whatever yesterday? Sine is negative pi over 2 to pi over 2. Cosine is 0 to pi. So everybody understand that? That bx minus c, that's where all this stuff is coming from. So your cosine goes like this. Consequently, on this interval, the cosine function has an inverse function. And the inverse cosine function is denoted by, it is the same thing, except for instead of arc sine, it is arc cosine x or cosine negative 1x. All right, similarly, you can define an inverse tangent function. By restricting the domain of y equals tan x to the interval negative pi over 2 pi over 2. The following list summarizes the definition of the 3 most common inverse trig functions. So the first one, y equals arc sine x if and only if sine y equals x. So again, we already knew that. It's just putting in a little chart for you. So everything that we've done, they're just putting it in a chart for you to memorize. Remember, this domain was from negative 1 to 1, and the range was negative pi over 2 to pi over 2. The next two are going to look exactly the same in this first column, except for it's going to say arc cosine, and then arc tan and tan y. So everything is exactly the same. So I'm going to fill in both of these. Arc cosine x if and only if cosine y equals x, and y equals arc tan x if and only if tan y equals x. Remember that not only did sine fluctuate between negative 1 and 1, but cosine did as well. But what's the difference in the range on cosine? 0 to pi. Right, so think about your tangent graph. Remember your tangent graph looked like this. Listen carefully. What was your range of this tangent graph that I just drew? Negative to positive infinity, right? So the range is now going to become the domain because we're talking about the inverse, right? So our domain, negative infinity, less than x, less than infinity. Your range and your domain switch. Do you remember what it fluctuated between? We did this yesterday. What did we set our bx minus c equal to for our tangent? We just said it. What interval? Negative pi over 2 to pi over 2. There you go. They do. What do you mean they switch? The domain and the range? Yeah, so here's your tangent. Your range was negative, that's top to bottom, bottom to top. Negative infinity to positive infinity. So now you're turning it the other way. So it would be your domain goes from negative to positive. Got it? And then we restricted this one, like each one of these little things happened between negative pi over 2 and pi over 2. So now we're turning it the other way. That makes sense? Is everybody good? So that's all we're doing is we're taking the domains from yesterday and switching them with the ranges from yesterday. So same thing on this, find the exact value. What about cosine square root of 2 over 2? Where does that happen at? Where are your square root of 2 over 2s? You don't even have to give me radians. Remember, you can give me degrees and we can fix it. Where does square root of 2 over 2 happen? At your 45. So this is 45 degrees, but I don't want it in degrees. I want it in radians. So how do I turn it into radians? 45 times pi over 180. 45 divided by 180 is 1/4. All right, so think about it this way. When is tangent 0? What is your ratio for tangent? Y over x. So which one has to be 0? Your y coordinate. Where is my y coordinate? 0. Think about it. 1, 0. Where's that at? 0, 2 pi, any increment of that. We're only looking on the first quadrant. Okay, so we're not going all the way around. We're just looking at that first quadrant because it's restricted between what? Negative pi over 2 and pi over 2, right? Okay. What about this next one? Where is tangent equal to 1 or -1? Put it in your calculator. Check this out. So you guys are, you get one you struggle with, that's okay. Tan inverse, -1. See what I get? What do I do? What do I have this in? I have it in radians. So let's try to do degrees and see what happens. Now can we change it? So this equals -45 degrees, but I want it in radians. This is the radians, but it's not in terms of pi. So how do we get it in terms of pi? Times it by pi over 180. And we already did this. What's it going to be? -pi over 4. Yep. Any way that you can see it on that unit circle, you used it. But again, if they ask you to put it in terms of pi, put your calculator in degree mode, find the degrees, and just radian. It's not that hard. Yep. All right. Now I'm going to show you how to use your calculator. Wait, I just did that, so we're going to do it anyway. It says use a calculator to approximate the value if possible. This is just decimals. So how do I do arctan? second 10, and I'm gonna put in negative 8.45. And I get. Nope, I'm not, I'm in degree mode. Hey, yeah, it's behind marker.
Well,
I don't know why we make y'all have so much time.
exactly. Thank you.
What do you even carry?
I carry your textbook, 3 notebooks, and a computer.
And my book bag's bigger than his.
Do I have it? I think y'all.
Thank
My
you.
book bag's got metal all over it.
Going back to. Oh my gosh.
Yeah. There we go. The principal understands what we have to deal with every day.
Did she show you any sympathy?
Yeah, she did.
No, she didn't.
She loves me.
She said, I would.
You say that about everybody.
Except for mom. His mom doesn't like him.
No.
No, my mama hates me.
All right, make sure, shh, shh,
Yeah, your
shh.
mama hates me
Guys,
too. I think your mama hates me.
guys. First of all, I'm recording. Second, I want to get this done. All right,
Your mom.
sign inverse 0.2447. Again, make sure you're in radian mode if you need to write that down. And we get 0.2472. I've showed you how to turn it into terms of pi. These will not be pretty to turn into terms of pi. That's why you just make it in radians. And then arc cosine, so second cosine of 2. What happened?
Error.
It does not exist because it falls outside of the range. So DNA means does not exist. Right?
Oh, boy. 2, 4, 7.
So we were both by higher than we
That'll give you a weird, a weird radian. All right, composition of functions, recall from previous sections that for all x in the domains. Of f and f inverse. Inverse functions have the properties. We did this like on the first test. If you plug the inverse into, you guys remember doing g of f of x? You guys remember that? Or the g and the little circle, the little open circle and f? So that's what it is. If you plug one into the other, it will reduce to x. And then you plug the other in, reverse it, should also give you x. So when you just plug them into each other. When you plug them into each other, they should both reduce to x. Inverse properties of trig functions. If -1 is less than x, less than 1. And negative pi over 2 is less than or equal to y, less than or equal to pi over 2. Which one does that deal with?
Son.
That is sine. How do you know it's sine? It's -1 to 1 and then pi over 2. All right. Sine. Arc sine x. It's like ln and e, how they cancel each other out because they're inverses of each other. Sine and arc sine will cancel out and just leave you with x. Or vice versa, if you have arc sine y, arc sine and sine will cancel out and just leave you with y. So that's exactly what it's saying up there. Like ln and e, arc sine and sine cancel each other out. What if we're between -1 and 1, but 0 and pi on the y? That's cosine. It is the same exact thing. So cosine arc cosine x equals x, and then arc cosine cosine y equals y. It's the same thing. So sine, not sine, you big dummy. Cosine. I'm telling you, you don't get to call me that
Why?
because we're not friends.
Yes, we are.
Mm-mm.
So what are we?
Um,
Acquaintances.
Pretty much.
How are we enemies?
There's no possible way we can be in.
All right. Then if X is between negative infinity and positive infinity, we don't have equal marks on there because there is no such number. That's just a direction. So infinity is not a number. It just says it just keeps going forever. Negative pi over 2 to pi over 2. That one is tangent. You write the same exact thing. Tan arc tan. X is going to equal X. And arc tan y is going to equal y. So that's just a random variable, just whatever value they give you. So if it was tan arc tan 4, it would equal 4. Sorry, y'all. All right, keep in mind that these inverse properties do not apply for arbitrary values of X and Y. For instance, arc sine of sine 3 pi over 2 Why would this value not work? What value is this? What should it be between? It's too big, right? It's too big of a value. So this would be equal arc sine of -1. Arc sine of -1 is negative pi over 2, which does not equal 3 pi over 2. In other words, the property arc sine sine y is not valid for values of y outside the interval negative pi over 2, which is what you just told me. It was too big. All right, so when I do tan arc tan -5, what should it give me? So we're gonna try it. Tan arc tan -5. Remember, I told you you don't have to worry about it too much. What does it give you? So it's within that range and those are compatible. The next one, arc sine 5 pi over 3. What's it give me? So what is that though? Does that work?
Initial value, right?
Mhm. But the value is -1.047. What is 5 pi over 3? Let's see what I'm saying. How far is it outside of that? It's like a whole unit circle, like a whole 2 pi. So if we change it, we can find that. I'm not worried about that. This is just what I'm telling you. You cannot cross these out because it's outside of that range. What about this one? Cosine, inverse cosine of pi. What happened?
Does not exist.
Why? Why doesn't it? Say it again. What? Why doesn't it exist? Read it.
Here,
Do good. It doesn't fit in that domain. That pi doesn't fit in the domain. It's like on that borderline, so it can't tell whether it's like increasing or decreasing. That's the only reason. It's on that
Because it
borderline.
says pi is less greater than or equal to.
Yep.
But it just can't tell.
I agree with you, but that's exactly why.
Oh, okay.
All right. Evaluating compositions of functions, find the exact value. All right, so this is one of the most missed questions on the test, and they're actually pretty easy. And it's because you start looking at arc cosine and you try to fix things and don't, okay, just treat it as like cosine. So all you're gonna do, go back to your trig triangle. Trig triangle. Pick either angle to be your theta other than your 90, it doesn't matter which one, so that you can do opposite, hypotenuse, and adjacent. Remember your opposite across from your 90, across from your angle, your hypotenuse is across from your 90, and your other side is your adjacent. It gives you cosine 2/3, cosine 2/3. Do not even look at this arc. What is cosine? A/h, right? So your A is 2. Your H is 3. How do I find my O? How do I find my O? Pythagorean theorem. So what do I set up? B squared, X squared, Y squared. I don't care what you put. X squared plus Y squared equals 3 squared. Again, I don't care what you put there. Put whatever variable you want. So I get 4 plus Y squared equals 9. How do I solve? And I get Y squared equals 5, and then take the square root. So your O is square root of 5. Don't try to fix it. Don't try to like flip it, do anything, because it says arc. Just use cosine like you're supposed to. You've worked on that part. Now you do your tan. What is tan? Opposite over adjacent. What's your opposite? What's your adjacent? That's all you do. That's it. Okay, so the arc really doesn't have anything to do with it at all. It's just telling you that cosine is 2/3. All right, look at B. Remember, don't look at this. Just look at sine. What is your sine? Opposite over hypotenuse. So what do we do? Which one is your opposite? What value is your opposite? Which one's your hypotenuse? Problem is, we have a negative, right? Please tell me that you know which one of these is going to be negative. Well, you definitely don't want the denominator. Well, you don't want it to be 0. Why is 3 going to be the negative? Not only that, but we want the longest side to be the hypotenuse, right? The 5. Not a big deal. What kind of triangle is this? 3, 4, 5. You could do Pythagorean theorem, but you should know 3, 4, 5. So we did the sine part. What is cosine? Adjacent over hypotenuse, which is 4/5. That's it. Write each of the following as an algebraic expression in X. You're doing the same exact thing. They're just not giving you values. It is the same thing. Okay, so don't take it any different. It's the same thing. So we're going to make our triangle. Pick a theta. It doesn't matter which one is your theta. You're going to look at the inside, ignoring the arc. What is cosine? How do I make 3x a fraction? So your adjacent is 3x, your hypotenuse is 1. How do I find my opposite? How'd you find the other ones? Pythagorean theorem. So I would do a squared plus 3x squared equals 1 squared. I'm solving for a. That's the side I need. What's 3x all squared up? And then 1 squared is 1. How do I solve for a? Minus the 9x squared. How do I solve for a? So this is the only difference. You have an expression in these things instead of having a value. So square root 1 minus 9x squared. You cannot fix that. It is good like it is. So we did the cosine part. What do we need to do now? Sine is, what was our opposite? Square root of 1 minus 9x squared. What was our hypotenuse? 1, which reduces to the square root of 1 minus 9x squared. It's just an expression, guys. So do not feel like you're doing it wrong. You do it the same exact way. You just have letters left over. That's all. Notice this one is exactly the same, except for we have cotan. We'll talk about that in a minute. But we have cosine 3x. I'm not going to do the work again because I already did it, but I am just going to redraw it for you. So we have the square root of 1 minus 9x squared, a 1 and a 3x, because it is exactly the same and we've taken care of that. What is cotan the opposite of? Tan, right? So tan is opposite over adjacent. So what would cotan be? Good. What's your adjacent? Here's your angle. What's your adjacent? 3x. What's your opposite? The only thing they may do is get that square root out of the bottom by rationalizing. But that's it. So again, don't look at that arc sign or that arc cosine. Just do it all the same way. All right. I'll work right down. Go write it down.
Thank you.
Page 326. I'm gonna write it down in a minute, but if you want to write it down at the same time. Page 326. 6 through 18. 22 through 38. 42 through 74. It seems like a lot. It is not, unless it's fitting in your calculator. Calculator basically until you get to 54, and then there's the triangles like this, and most of them are fairly simple triangles.
So again, here's your homework.